finally, my last piece of static electricity is charging by induction. Again, another little story for you to read. Imagine kids in a classroom and something really exciting is happening outside their window. So extra kids come and join the classroom to see what's happening. Make sure you've read through this all, but I'll talk you through. That's my analogy for charging by induction. I'll get you to check out the little clip for induction. It sort of freezes up on the iPad, so I'm not going to show you here, but you can watch that if you haven't already. Let's say we've got something really positive. Oops, that's a little bit messy. Let's try that again. Let's say we've got something that's positive, and close by but not touching, I've got something that's neutral. If we connect the neutral thing to the ground, grounding is a very cool thing in static electricity. When we say we've grounded something, this is our symbol for grounded. When we say we've grounded something, really what it means is we've literally run a wire into the earth. And since the earth is so big, that makes it free for electrons to leave the earth and go into the object, or vice versa, leave the object and go into the earth. So I kind of typed it over here. When we ground something, we basically make it free for electrons to move out of the ground and into the object, or the opposite, electrons can leave the object and go into the ground. Because the earth is so big, it can give electrons to the object, or it's got room for more electrons to leave the object and join it. So back to our little diagram here, our charging by induction. If we've got a positive object close to something that's neutral, but the neutral thing is grounded, since opposites attract, we're going to get a little stream of negatives coming up out of the ground and into the object. They're going to get attracted. They want to be close to the positive. Then if we're careful and we separate them, the positive is still positive because nothing's touched it. If we separate them and then remove the ground, those negatives that came into the neutral object are trapped there. So the object that started off as positive created a negative charge. That's how charging by induction works. Without contact, negatives were pulled out of the ground to join the neutral object, making the neutral object turn into negative. We could also charge by induction the other way. If we start with something that's negative, and we bring it close to something else but not touching it, but that something else is grounded. Opposites attract, similars repel. Electrons are free to move. So in this case, negatives that are in the neutral object don't want to be close to the other object, so they're going to leave and go down and into the ground. As we talked about before, if negatives leave an object, that object ends up becoming positive. So if we're careful, separate them, then remove the ground, negatives have left the neutral object, meaning that neutral object is now positive. The negative one is still negative because we didn't touch it, but we created a positive. That's charging by induction. We have to have a ground wire, to a place for the electrons to either go into or a place for the electrons to come from. Electrons will get pulled towards a positive to make a negative charge if we do charging by induction in that way, or if we start with a negative, the electrons get pushed out of the neutral object to turn it into a positive object. So a cool thing about induction, it is a little bit weirder, but we end up with the opposite charge from what we started with.